In this video, we're talking about the Geometry Arizona Merit question number 19. And if you have that paper in front of you, you'll see that it has a table on it. And the question is saying this: Jackson has a table with a square top and he wants to buy a circular piece of lace that will cover the entire top of the table. The top of the table has side lengths of 12 inches as shown. What is the area in square inches of the smallest circular piece of lace that Jackson could buy? Round your answer to the nearest tenth. Now, I don't know if you can see this. Even on yours, it's kind of hard. But he's got a piece of lace on there, but it comes down a little bit. That little lace comes down a little bit. In any case, so here's let's say his tabletop, and it's 12 inches each, or all the way around. Well, you might think, well, then the radius is 6, right? And then to find that, you would say, okay, area equals pi radius squared. So you would go 3.14 times 6 squared, and you'd multiply that out and get an answer. But if you do that, it'll be wrong. Let me show you why. Let's say I put a radius there of 6, a radius here of 6, a radius here of 6. Now let's draw this picture, if we can. Connect these dots. This dot goes like this. Like this. I'm doing the best I can. I mean, it's not great. But look what happens. There's a bunch of stuff here that's not covered. You see that? Kids, this is why drawing a picture sometimes, even though maybe some of you guys especially feel goofy doing it, it's going to show you right away, hey, that can't work. Because all of this stuff is missing. See that? What if my radius was this long, or this long, or this long, or this long? Now I'm going to draw my picture, my circle thing. I mean, this is the worst picture ever in the world. But you see how it goes off the table a little bit? So let's just redraw this real quick. Watch. So if I have this rectangle, square, excuse me. Okay. And let's say then I want this to be my radius. And this is not my radius, but whatever. All right, so the whole, remember, everything is 12. Well, how long is it from here to here? 6. How long is it from here to here? 6. How long is it from here to here? Well, you might not remember. You might not be able to figure this out this one way. But can't we use the Pythagorean theorem to find out how long, because this is a right angle. So we can't we figure out what c squared is going to be? So look, a squared plus b squared equals c squared. So far, so good? All right, so 6 squared plus 6 squared equals c squared. Well, that's going to be 36 plus 36 is going to equal c squared, right? Well, 72 equals c squared. Now, let's take the square root of that. And let's try doing this on the calculator, although, we could do it one of two ways. We could either simplify that, or we can do it on the calculator. So let's see what we do. Let's see what happens if we put get that number. Because we're really trying to plug that number in to find out what our circle is going to be. Remember this? Here's our circle, and our radius is now, well, this is what we're trying to find out. It's going to be radical 72. So I'm going to go second radical 72 equals 9.485. 9 0.485 is the radius. All right, well, let's see now what that will be after we do the circle. So area equals pi r squared. So area equals 3.14 times 9.485 times 9.485. All right, let's just do that on the calculator and see what it is. I'm sorry, kids, it's 8.485. Hello, I didn't read this right. It's 8. Sorry. All right, so 3.14 times 8.485 times 8.485 equals 226.06. And they're asking us to say it to the nearest, what? To the nearest tenth. So 0.065. All right, so to the nearest tenth, that makes that to be 226. This makes this go up to 7, and this makes this go up to 0.1. Okay?